Hello everyone, I hope it is clear. Okay, so let's start. So today what we're doing is going to continue with yesterday's work of creating an environment. So we were learning about basics of RL now and OpenN. Now we'll start with creating a proper RL environment. So our goal is threefold. One, learn about RL. Second, create open-end environment. Third, finally use that environment to train our model. Okay, using the RLVR algorithm or the reinforcement learning with verifiable rewards. That is what we nowadays use for our LLM. Okay, so what I'm going to do is I'm gonna first plan on what all I need to do. Then I'll start. Okay. Uh, let's first read what was the last message. Go ahead. So we're actually doing it for this, but this is already over. So we'll still continue it. Yeah, I think so. It's is it not over. Just first try to record and see like it's over or not. If it's not over, then it's very good. We can create it. Haha. Okay, I guess the so according to this, the deadline has been extended, which is the amazing thing. Now we can finally learn how to work with OpenN and create an RL environment that is useful. So let's see if we are able to do it. Okay. Uh, okay, let's close it. So we have time till well. So this is also should be right. If they're doing till 12. This should be 14 to 16, and then penalty should be 25 to 26. Okay, well and good. Let's proceed. Yay. I think the universe is in our favor today. So let's proceed. Let's build the scatter for the stateful Python execution environment step by step using verifiers. Oh, I don't want to use verifier. I want to use primary verifier fully open end. Just a Python class operator. It's interesting. It operates as a microservice. Yeah. So OpenEnd actually, because we learned yesterday that OpenEnd creates a fast API server with Docker environment. Yeah. So interesting fact, right? So a similar environment. The reason why OpenEnd uses a Docker environment is because it allows the model to not hack its environment or do any implement any malicious code that it might think is required to achieve good reward for its uh, task. But interesting fact is, so with that context that it cannot execute outside the environment, it is not it cannot hack its reward, etc. Anthropic released Mythos, which they claim was able to exit its environment and call its researcher saying that the task is done, which is crazy. Like the whole idea of OpenAI is to not be allow the LLM to be able to go into the real world and hack its rewards, etc., or execute anything on the computer to that might cause harm or data loss. So yeah, okay. When to use open environment, and environment isn't just a Python class input into a script. Your other thing include the client communicator that value HTTP. Let's just confirm. I need to confirm the timing also till when it's extended. Let's see if how many people are there in this channel. Hmm, we can see that. Okay. Yeah, let's continue. So to build this, we have to implement OpenApp Score, orchestration, endpoints, reset, starts, and exert, step, uh, agent sends an action like executed Python, and the environment runs it, calculates the rubric score, and returns the observation. This introduces a classic web engineering challenge. Into our RL setup, HTTP is fundamentally a stateless protocol. If your agent calls reset, it has to start a new Python coding task and then call step a few moments later to execute a line of code. How should our OpenApp server keep track that specific comment? Hmm. It needs a state class too. Hmm. Work. Reset is called. The server generates a unique session ID and boots up the isolated Python execution environment. It then tells the state manager to remember this new environment. Step is called. The server receives the model's action, the code along with the session ID. It asks the state manager where the Python environment for this specific session so it can execute the code in the right place. You building a simple prototype. What is the most straightforward Python data structure we use inside a state class to map a string data structure we could use dictionary or a hash. What we need. The dictionary is a key value store. It gives the server instant lookup. The background state manager simply maintains something like active session is equal to x blah, blah, blah. Okay, so let's trace the full step execution path for our OpenM microservice. So, fast request and was request containing the session ID and the product action. Um, the server uses the dictionary to fetch the correct active sandbox for that specific rollout. The sandbox runs the code, calculates the reward, and using the sorry, just one more thing I forgot to see in the Discord chat. Okay, so today is so it is still Sunday end of day. Just good. Right, let's do it. Build the world's best. Okay, the sandbox runs the code, calculates the reward using the rubrics, and returns the observation back to the trainer. Focusing on step 3, raw text string and run it down. Hmm. So I think we should do is two things. We can learn from this also that they have included, which is cool, I guess. When you pass a string of text into a def, Python dynamically compiles and runs it as a oh, other runs it as a so putting it all together in some step process. So receives a SGB request containing the session ID and the code. It looks up the active sandbox in Oracle. It runs the exact code inside the executed sandbox. It evaluates the result. It improve it. It calculates scope. That is the results and send an HTTP response back. Like Gymnasium, which open and taking a step always returns a set of variables. We know one of them is what. What are the critical pieces of info must the environment send back to the LLM. So the LLM knows what happened and can decide on the next. All result is a syntax. It is a syntax error, sent back, that is sent back on the output of the code back and expression. I'm not sure if this is the correct way to learn because I feel like it is missing few things. Oh, you ran output and syntax error in RLW, the observation. It tells the model exactly what happened when it ran the code, allowing it to read the traceback and fix the mistake in the next turn. However, let's pause on session ID. Think back to our discussion about the model trying to hack the environment. If we send the session ID back in the observation. Ah, so with text mapper, we don't have session ID. Other than that, we have session ID. So for a couple, so for a complete step, so for a complete step, the server sends back the observation, the code output, and the reward. For the step, uh, like the observation, code output. It will be so the LLM's code was perfectly correct and the task is solved on the model has made 50 kilometers. We want to cut it off to save up the fuel. We need a way to stop the loop. Yes, simple. I think it is more and more going into prime RL territory rather than this thing. So what I'll do is I'll make it do a deep research on whatever there needs to be known about OpenN, on creating efficient OpenN, create a prompt, create a prompt. So bad. Why is it so? Create a prompt for research on OpenN. Create environment, basic to advanced levels. Failure modes, failure. What I'm going to do is I'm going to do a deep research on this so that I have a better understanding, so that the model also have a better context. Uh, okay, so I also had this thing. What was it called? Solve it, yeah. So we can also do it here. Do a deep research and see. I don't know. A deep research. See if Solvit is working right now. So let's go. Okay. So let's go in the time that it is doing its research. So just go through the video that they created.
Okay, the ends are in their like running and usable state, right? So this is where the ends are distributed. This is where they're deployed. And this is also where you will distribute and deploy your ends, and that's how you'll submit, right? So if you just take a look here on the hub, you'll see there's a README here that is in fact almost exactly the same as the GitHub one, just a bit more concise. It gives you the snippets there that you'll need. Down here, you'll see these collections. These are probably the most important place to come. you'll see a set of collections for different environments. Here's just a mixture of the latest ones, Environment Hub v 2.10. That just means that these environments align with that version of the software. All the others are kind of just like categorical, like we've got some real world agents here. So a calendar environment, a reasoning environment, web search environment. You might want to pull these in packs, or if you were using a multi-environment. And then we've got like the reasoning games there, and they're just kind of categorized. Okay, so your objective will be to, as I said, to publish one of these ends, and that's what I'll show you first. And the other part will be to publish a blog post, and I'll also show you that. So everything I'm going to say is based on a tutorial, which is also in the GitHub repo. As we've heard before, OpenEnv, also meta/pytorch/OpenEnv, and just go to this tutorial directory. And what you have here is actually a kind of repetition of other information that's spread out, but it's a bit of a like one-stop shop where you can come and kind of go end to end and walk through the process. So it's a nice tutorial to go through. You'll see that there's a first page, environments. That is really a repetition of everything that Sanyan went into, and so we won't.
So I think the tutorials page is important. Let's see if we can provide that information. I don't think so we can give information in the middle of it. Can we? I should have given the tutorials page. Fine.
And just create that.
Won't go into that now, but it's just in a markdown format, so you can just kind of read that. Works quite nicely on mobile, but it's probably not the best way to kind of build on top of it. You might want to go to the notebook to build on top of it. Then there's a deployment page. That's what I'm going to focus on. And then we've got another page on scaling. So this is, let's say you've got this ends and you want to go to multiple GPUs or multiple devices. That will show you how to deploy those ends. I won't touch on it today, but it's pretty cool and it's worth reading. And then the fourth page is on training, and that uses TRL. And so you can go into that and get an example of training. And we've also got some example notebooks. The one that Sanyan showed, a tutorial, a Wordle example in TRL, and the Unsloth example that Daniel has already shared. So that's like a one-stop shop you can come to inside the OpenEnv repo. This is the page that I'm going to start with, and it's called Deploying an OpenEnv environment. Okay, so as I said, all of the environments are on the hub. And they are on the hub as spaces. So you'll come and you'll find them all here just under spaces. So like with all the sort of computer vision and various other demos that people deploy in spaces, we'll also have environments here. Now, something that isn't fully known about spaces, actually internally and externally, is that they have three interfaces to them. They are at the same time a server, so you can access a URL of them and use the application running. They are a repository, a code repository, so you can pull and push and commit code to them. And they are a Docker registry, so you can pull that application as a container and use it as a container. So there are many other projects that take advantage of spaces in this way. But OpenEnv is one of them, so it kind of uses spaces like to the max, let's say. So if you come here on the hub, you'll see there's a button here, run locally. It'll take a while to render. Maybe it won't render. Okay, I'll have to try another one. But first, go back. Let me try this one. There we go. So what we have here is a Docker run command, and this gives you, in this case, for a certain platform, you need to change that, but it gives you a Docker tag that you can use to run this space, and you can run this space locally. You'll also see here clone this repository, and it'll give you a git clone command, so you can pull the code. And up here in your browser, you've got the URL that you can use to interact with it like an API. So you have those 3 points, and that's shown here in the tutorial. So how do we run a server? An env. How do we use an env within our Python code? Okay, so the first example is to use it like a server, use it as a remote space. And so in OpenEnv, I can just instantiate the echoenv class, and I can pass that URL to it, and then I can use it as Sanyam showed on that space. So I'm using the space infrastructure. Now we benchmarked this, and you can get up to reasonable batch sizes. So all of the tutorials that we've shown you in Unslark and TRL, they run with spaces on the free hardware. If you go up to kind of paid tier on Colab, you might then need to also pay for the Colab in order to keep up with that speed, but you're still talking in the cents. And you can go up to a reasonable batch size while still running completely on spaces, which is pretty cool because it means that you don't really have to think about Docker or anything else. That said, there's more to the end, right? There's the client code. So how do you get the client code that you're looking at right here, like all of this? How do you get this library? So for that, we take advantage of the space as a repository, and we say pip install git the space. And then we can install the client code and run the client code and interact with the server. So that's the great advantage of this is that we've interacted with the same code, right? So we don't really need to worry about versioning as long as we're pointing at the same space. The final way would be to get the space, would then be to use it as a Docker to pull the container, and so Docker run pass the URL, and then we can run the space locally. And in order to use that in OpenEnv, we would then need to pass the URL to that same class and say, okay, this time interact with a locally running container. Cool. So that's basically the quick way of getting to that same space from 3 different angles.
Okay, let's read some.
Let me start with a little bit of context around RL and preface that as to why did we decide to open source open environments. So the goal of RL is to teach an agent from experience. Of course, we're like much ahead of that, but very simply put, with an example, let's say you're trying to teach your dog to sit down. The dog is learning from observations. And initially it's not very learned about your words. So when you say sit, maybe it barks or does something silly. And the observation it will get from you is maybe it gets a scolding. So based on its action that it chose, it'll get a negative reward from you. In this example, your dog is an agent. The observations you're giving it are either a scolding or a treat. And this is an episode of learning where at every step there's some interaction happening. So this is the crux of reinforcement learning, and these terms have been around for a while. So for those of you, I'm sure I don't need to educate everyone here about this, but just for the sake of completion, any RL loop has these 4 concepts, which is resetting, where you start a new episode of learning. You have an observation, which tells you what's going on in an environment. An action is decided by your agent. So in our example, it's sitting down, spinning, barking, or doing something silly. And a step is taken at every single interval of the episode of learning. So the pattern is kind of universal. Your agent will observe, act, it will get a reward, and hopefully learn. The hopefully is actually really hard, and Daniel will talk about it. It takes more than hope. But when you try to apply this to LLMs, a quick problem is obvious. I'm just referencing some open environments that are out there. But you can imagine that when you're training your LLM with something like a word class training API like TRL, or if you're running on Colab, maybe using Unsloth, um, you want to focus on improving your LLM and not writing plumbing code. If you try to connect different environments, it's basically different API specs that need to talk to each other. And this will block you from moving fast. So this is a pain point we're trying to solve. Where in your training loop would ideally look like this. And usually you're not hoping to teach your agent just one thing, right? You don't just want it to be better at programming, you want it to be better at many things. So in an ideal world, we want to get to a stage where you can import from any environment, and all you do in your training loop is change the first line. So you go from Android environment to, let's say, computer control environment or something like that. And you're using maybe TRL or Unsloth. Anything else in your training loop should not change. That is the goal we're trying to achieve with OpenEnv. So in an ideal picture, the RL algorithm is handled by your training API. You download your LLM and you're just changing environments which are brought in from OpenEnv. And hopefully this makes it a universal interface for you to be able to teach your model or your agent any given task. Now, to make sure that this is a success, we have defined a nice set of specifications and we have a solid set of RFCs. I'm going to only talk about a few of those, but I invite everyone to find them in our GitHub repo. If you do not agree, please roast us in the issues or send any complaints you have to us. We're doing this for you, and we're doing this because we care about making sure everyone can train their agents in the open. So we'd love your feedback, but
Let's just say define types, model.py, action observation state database, implement environments, reset step state methods, create clients, HTML client subclass, create server, authorize.
the starting place that we've decided is let's use the same concepts that Gymnasium API has used. So step, reset, and state. And let's package that in Docker files. So once you try to scale your training beyond one GPU, it's easier to scale that with Docker. And to make sure all of this is using the same spec, you can package these under the same specification. This involves the following 5 steps that you can see on your screen, and I'm going to use an example. You do not need to memorize this. Ben will show you how easy it is. You just need to use RCLI, which will initialize a skeleton of all of these files. And then with just one command, you can push to Hugging Face up. So in reality, it's very easy to get started, but it's these 5 steps that take or that you need to take to get there.
These are the 5 fundamental steps required.
So let's look at a real example. Let's look at Connect 4 game. I've never won this game. I tried cheating and I'd always get caught. So I'll only reference what's on the screen. But let's say in the model's definition, you have to first of all define an action and observation class. So an observation in this case would be the board of the Connect 4 game. And of course, you'd also need to define what legal actions are allowed. These sort of limit what your LLM or your agent, maybe you're not using an LLM, can do. And then you have to keep a track, is the game finished or not? And what's the reward? So you define all of these in the model definition. And in your environment, you expose the behaviors. So when you reset the game, basically you clear the board, In this case, you just create a NumPy array. Sorry, it's not visual. It's a simple NumPy array. And honestly, most environments are really simple when you
Class connect core and set wooden non set dot so piece. Data class board legal action.
try to think about them. In a step, you're just dropping a piece in any of those columns in that NumPy array. And then finally, you'd want to package this in a fast API server. So you define that in app.py. And I've not shown it here because it's straightforward, but then you want to package this in a Docker file. So it's easy to download and easy to talk to. That's all it takes to define your environment. And once you have that, you can imagine your training loop then becomes just grab this from the Docker image and let Unsloth do the magic on top. As you scale your environments, I'd encourage everyone to just think on these patterns and spend more time thinking about what you want the behavior to be rather than the patterns, because honestly, the patterns are really straightforward, and hopefully they are after this quick intro.
Let me see that. I will just go through each video and
Or moving on, we can run the Docker container and use the same example. We can pull the container and then, we can clone the repo and then make changes to it and then build the Docker container as well. And inside the OpenEnv CLI, we've got like a convenience tool, OpenEnv build, that does that for us. But it's essentially just wrapping Docker build, so we can also do the same there. And then we can run these containers and, as I said before, connect with them from Python in the same kind of way. So what does it look like from the CLI? So as we showed before, you can do this OpenEnv init and you can create the skeleton, and then you can push that straight to the hub, which I'll come back to in a second as a little demo. And then you can configure that environment mainly with environment variables to say like how many workers do you want to use and whether you want to use concurrent environments, which I'll come to in the next section. So feel free to kind of drop in any interruptions if you like. I'm just going to set this up so it's a little bit easier to see.
Yes, I had a couple of questions. Like basically, so I know you mentioned at some point, like, oh, if you don't have like Docker, you can use UV. But like, how does this work? Like, I mean, presumably most environments aren't written in Python. Like, if you're a Pokemon, you're written in like, whatever that was written in. Then you have like some shim in Python. So, like, could you speak to how like basically native code gets deployed in environments on the hub?
Yeah, so when the environment is outside of Python, you need to use a container to define the code outside of Python and do dependency management, basically. So if you say like, if you want to run the Uvicorn application, the Python application, yeah, you can't, you'll need to manage the dependencies outside of Python, and we'll do that with Docker. That's basically, yeah.
I see. I know this may be a pedantic question, but just because you have cost there. So the cost basically, it's like, is it like paid for by the people hosting the environment, or is it paid for by the people that are pulling the environment? How does this work if people are having like multiple rollouts where they're doing multiple parallel evals?
Yeah, so in the example I showed you, where like this kind of example where you interact with the space itself, right? Like the environment host would pay for that compute, and so in most cases, like if you're publishing an environment, you would probably want to do that for free and just let people try it out and kind of understand the environment that you used, maybe learn from it, and then they could pull that environment and run it for free. because of how spaces works, like let me just maybe show you, like you can just duplicate spaces, so they're kind of like super easy to just pull over to your
I
own
see.
scene.
Like running locally is something you want people to do. Like you want
Yeah,
to discover
totally.
things, and then like I see.
Totally. So yeah, I expect most people will like come here and like try it out and learn from it, maybe duplicate it if they want to make changes and share it. But in most cases, we expect people to kind of to run this locally.
Got it. Okay.
Cool. So yeah, okay. So I shared this little demo, and we've kind of seen this a little bit already, but let me just work through it. So you basically just do openenv init, which looks like this, and it's a simple command line. It just needs to know what the name of your environment's going to be. So let's call it GPU mode. And so you basically, I'm in the right place. Okay, sorry.
Sorry, I just had a quick add to what Ben answered about Mark's question. For like most of these game environments and things like that, you can imagine you sort of building adapters or wrappers, just like add on to the spec. But our goal for like hopefully this year is we'll build like environments on the ground up, so we'll see them like being less clunky. And the other thing I want to call out is like most of these are for reinforcement learning training. So that will go in a lot more depth, but the CPU cost of running an environment compared to like the GPU involved in training is like really fractional. So you can imagine like you probably would not mind hosting these on your server. Sorry to interrupt.
No worries. It was actually extremely helpful. Gave me a chance to get this back in line. So yeah, okay. As I was showing you, this is just how you initialize an environment. So, and I just want to kind of work through that. So let's say I'm going to create a new environment called GPU mode. So I just say openenv init GPU mode, and it creates that for me, and it tells me that there's this new file called openenv mode. So let's go and have a look at that. And if you look over here in like the file explorer, this is what it looks like, and this is the skeleton. So it comes out of the box. So if you're looking on the right pane here, and it comes out of the box with this README that has some metadata, which makes it discoverable on the hub, basically. But also gives you like the templates, and you'll notice that we've like sedded the entire skeleton so that it's already pre-constructed for you with the name that you chose, which in my case was GPU mode. And it gives you all of these examples of how you do it. So out of the box, you have like a self-contained, fully documented env that is also interoperable and standardized and uses openenv. It comes with this PyProject TOML, which installs all the like the base dependencies that you need, and then gives some like recommendations and gets that running. And then it has the client code itself, which Sanyam already kind of unpacked and went into detail on. And that's all that, right? So then let's just change into that. Probably don't want to go too far into this because we want to go into the some other things after that. But we can then basically just like run this env like this locally. Sorry, that port's already in use. So yeah, okay, that's it running locally now. And then if we go to our like Python interpreter, I think I have that here. So okay, if I did that, I think it wouldn't work because that's not deployed. But if I copy the URL out here, then I can just say, okay, run on here. Yeah, okay, and then it's like step through, and it's a reward, and then another reward. And that's this openenv environment running here. And then let me just now go back to my terminal, close that down, and do openenv push. Hopefully I'm in the right directory. I was, yeah. Cool. So then that's now pushed it to the run on here. Yeah, okay, and then it's like step through, and it's the reward, and then another reward, and that's this openenv environment running here. And then let me just now go back to my terminal, close that down and do open push. Hopefully I'm in the right directory. I was, yeah. Cool. So then that's now pushed it to the hub. And if I go over here, open the browser, you see that I've got this space running here, OpenEnv. And then I can just like test out the env here. And this is just a skeleton env that just like echoes back whatever you ask it. So it's just echoed back hello. But if the env was like more complicated, or let's say it was like Sudoku or Textarena or even browser control, you could try that out and kind of get a sense of how that environment works and what the model was doing for this use case, like in the space. And then you would be able to, as I show you, go here and kind of duplicate it, embed this space, but you could also run locally, and then you'll see this Docker run command, which is the same Docker run command from the docs. I think this should just drop in. Yeah, and so then now what you'll see it's doing is that it's running the same container image from the space inside, like locally, but this time via Docker instead of the Python server, the FastAPI application. So that's it. Let me see if I can also just interact with that like that, just to kind of complete the loop. I think that one should work. Yeah. So now you've got like the same application running in the space, which you can also use.
Right.
But first, I'm going to show you the project and how we create a project. So I'll switch over to the IDE. Zoom in a bit because it's always difficult. And so I'm just in an empty directory here. I've got a virtual environment and I've installed OpenEnv from pip, like the stable version. And I'm just going to do OpenEnv init, and I'm going to say play, and I'm going to hit return. And the CLI walks you through scaffolding this environment. And so I'm going to change into that environment directory that's just created. But you'll see here that it's got some nice documentation that just comes out of the CLI, tells you where it's created this env, and tells you how to run it as a Docker container. Let's have a look at what it's created. So it's actually created a pretty big template for us. And if you go in, you see here, it's taken that name that I gave it, play. So it's created play _ environment. I'll push this down for a sec. And you'll see that it's like cutting all the names of the envs that I want everywhere. And it's created this full template for us. And so in essence, it's given us all of the boilerplate. We just have to come in at this point here and start to add some business logic, right? Like, what is the end going to be? What will it do? And really, we can do that. And in fact, the env could be used as is. Like, the scaffold could be used as an env. It would just give you zeros all the time. So you can really start with quite simple ends and building out this business logic in the reset step methods. So let's say it's a game, you'll know that the step will be the steps through the game, and the reset will be, let's go back to the beginning of the game, etc., etc. And you can use the scaffold to do that. It will also give you a Docker file, as Sanjay went in. Everything is based on Docker. In most cases, you won't really need to touch the Docker file. Unless you use something outside of Python, I'd say you can probably just leave the Docker file as it is. So if you're building a Python-only env, just move on. Likewise, there's a project TOML, and you can use the project TOML to install dependencies. You'll probably need to use that because you'll probably use some kind of dependencies. So this will be a first place that you come. And another thing that you should check is that you're using the right version of OpenEnv with the environment that you're using. You might want to install it from source. You might want to pin it. I definitely recommend pinning the env when you deploy it, when you share it, because if you attach it to the GitHub repo, it probably won't remain stable. So you should definitely freeze it when you publish it. And that's the main way to do that. Right, so that's the code side of building an environment. The other element to take a look at, the other piece of code, I suppose, would be the client and the models. And they will need to correspond to the business logic of the the environment that you set up. So here you'll see this is based on the EchoM, so it's message and then the echoed message. For a game like Wordle, it would be like guess and then score, something like that. So you need to define the business logic here again in models and then in client to make sure it's used. So those are your two sort of like theaters of operation, let's say, models and play environment. Right, cool. Okay, so now let's publish the end. Open and push. And I need to pass a repo ID. In fact, I don't need to pass a repo ID, but I'm going to, yeah. Cool. So that's now published that to the hub. As I said, I don't actually need to pass a repo ID. The OpenMCLI will just take the name that you've configured in here and use that as the repo name. So that's available, but if you want to specify where it's going to go on the hub, then you just pass that repo ID command. If you've used if you've used the Hugging Face CLI, then you'll find the OpenMCLI really familiar because it uses all the same parameter names and stuff. And this is that end that I created. It's just starting up now. Here's one that I created earlier while I was practicing, and it's there sort of ready to go. And it works as an echo end on the hub. Okay, so that's it. You've published an environment. The last thing is to post a blog post about it, and I'll just show you how to do that. That's super simple. You just go to your profile on the hub, and you click new here, and these are like all the new things that you can add on the hub. You just click article, and you have a markdown editor. You can write in Markdown. You can preview it just like any other Markdown editor. Feature that we've added last week actually is that you can see all of the articles that you're drafting, which is pretty handy. I think something that's probably useful for this would be to note that you can set co-authors here, and that's just the other users. And when you do that, it will show up on the hub. Let me just show you. It will show up on the hub as your co-authors. Look, there's a great article here just published by Daniel and I, just coincidentally. And it will render the names of the articles of the authors on the front here. So if you did the project like with other people and you want to credit them, then make sure you include their usernames, and they'll be there shown as well with their avatars and everything, and it will link to their profiles. Other than that, it's pretty straightforward. You just populate the URL with whatever you want that's available. You can set a thumbnail, which is pretty good. Some people forget to do that. I definitely wouldn't, because it just looks way better on the landing page. If you have a look here, like this person forgot, it kind of doesn't look as good. But these people remembered, and it looks a bit better. And that's it. Then once you're done, you just click publish.
Okay, cool. So we have learned few things here and there, went through the video stack. I will take a break and come back.